Hi everyone, welcome to AI Exact channel. This is Akash Ungwar and today we'll be studying progressions lecture 1. So we'll be starting with arithmetic progressions. So let's start. So AP is a sequence whose terms increase or decrease by a fixed number and this fixed number is called common difference. So basically, let's say we have the series 1, 3, 5, 7, 9, 11 and so on. So you can see that the numbers are increasing by a fixed number called 2 and that's a positive number. Now let's say we have the series called 1, 11, 9, 7, 5, 3, 1, minus 1. So over here it's decreasing by a negative number that is minus 2. So here common difference is 2, here common difference is minus 2. And let's say we have a series like 3, 3, 3 and 3 and so forth, so on and so forth. In this case it's increasing or you can say it's decreasing by a number called 0. So over here common difference is 0. That is also arithmetic progression. So here we have defined certain terminologies. So the first term is always called A and common difference is always called as D. Regardless of it's a positive number or a negative number or even 0, it's still called as D. Okay. Now let's try to understand the general term and sum of AP. So let's say we have this term A and we are adding D in it in the second term. So A plus D over here. And in third term, what we'll be doing, we'll be adding D in this. So we'll be getting A plus 2D. Similarly, we'll be adding D again. So that would give me A plus 3D and so on. So this was our T1 first term. This is T2. This is T3. This is T4. And similarly, we'll be getting Tn. Okay. Now you can clearly see that if 1 is over here, then we have 0D over here. If 2 is over there, we have 1D. If 3 is over here, we have 2D. If 4 is over here, then we have 3D. So basically, if n is over here, then we'll be having a plus n minus 1D. We'll be having n minus 1D, right? So this is our general term for AP. Tn equals to a plus n minus 1D. That is very, very intuitive. Now, if we want to write the sum of AP, in that case, let's denote it as Sn. So we'll be writing A plus D plus A plus 2D. And similarly, the last term would be A plus n minus 1D, right? Now I'll write the sum of n terms, that is Sn, in the reverse manner. That would be A plus n minus 1D plus A plus n minus 2D plus A plus n minus 3D and A over here. Now if I try to sum it, and what I'll be getting 2A plus n minus 1D. This number would also be plus 2A plus n minus 1D, right? Similarly, this number would also be plus 2A n minus 1 plus n minus 1D till the n term. That would also be 2A plus n minus 1D. Now this is 2Sn. So basically these are n terms because we have written from T1 to Tn. So these are n terms. So that would be n times 2A plus n minus 1D. And this is equals to 2Sn. So Sn would be n by 2 times 2A plus n minus 1D, right? So this you have to remember. You have to remember two things. Tn equals to A plus n minus 1D and Sn equals to n by 2 2A plus n minus 1D. Now the interesting thing over here is this this summation. We can clearly see that the first term and the last term is equals to this term, and also this term and the second term and the second last term, that is also equals to this particular term. But we'll be remembering it with the help of first term and last term. So you can also say that n by 2 equals n by 2 times a plus l. A is the first term, l is the last term. So this is how you have to remember the alternate version of summation. Okay. Now let's look at one question. The number of terms common to two APs 3, 7, 11 till 435 and 2, 9, 16 till 709 is. Now in this question we have given two APs. First AP is AP1, that is 3, 7, 11 and we have 15, we have 19 and so on and so forth. 23 as well, so on and so forth. Okay. Now you can clearly see that over here a equals to 3 and d equals to 4. Now in AP2 we have 2, 9, 16, 23, 30 and so on and so forth. Now if this is the case, we can clearly see that the first term is not common. So we have to, if we have to find out the common terms, so we have to find out the first common term, and after that we can apply the common difference for both of the APs, right? So over here it's starting from 3, it's starting from 2. So we have to find out the first common term. So now I can clearly see that the 23 is the first number which is common to both the APs. Now after that we can start applying common difference which is common to both APs. So how to do that? Let's say we have two APs. For example, we have 3, 6, 9, 12, 15, and so on. And the other AP is 1, 3, 5, 7, 9, 11, 13, 15, and so on and so forth. Right? Now you can clearly see that the first common term over here is 3, and the second common term over here is 9. So we have a jump of 6. But if we talk about just this AP, we had a common difference of 3. If we talk about just this AP, we had a common difference of 2. Now I can clearly see that the common terms, the AP which is found by the common terms, in that case, the common difference is 6. And that is the LCM of 3 and 2. So over here, we can apply this similar concept. So we have a common difference of 4 over here, and we have a common difference of 7 over here. So in the AP of common terms, we'll be having common difference, let's say D dash, that would be 7 into 4, because LCM of 7 and 4 is 7 into 4, that is 28. So now the common AP, the first term of common AP is 23, and the common difference of the common AP is 28, right? Now we have to find out the number of common terms. Now, one thing is pretty clear that this AP, the first AP, which is having the last term as 435, that would act as a limiting condition. Why? Because the last term, that is 435, is lesser than the last term of 709. So basically, we have to find out the common terms with these conditions: D dash equals to 28, A dash equals to 23, in this particular AP, right? So Tn should be less than 435. It might be 435, it might not be, because it might be possible that the having the common difference as 28, the terms are actually ending just before it, because it's an even number over here. It might divide, it might not divide. So Tn should be less than 435. So A dash equals to 23 over here, D dash equals to 28 over here. So Tn, if I want to write Tn, that would be 23 plus n minus 1 times 28, and that should be less than 435. So I can clearly see that 23 plus 28 n minus 28 is less than 435. So this becomes minus 5. 28 n is less than 440. So basically n is less than 440 divided by 28. So 4 7 times and 411, and if I do, that would become 15 point something. So n is basically 15 over there. So D is the correct option. Now let's look at this question. The Sn denote the number of first n terms of AP. If S2n equals to 3 times Sn, then S3n is to Sn is equals to. Now Sn equals to n by 2, 2a plus n minus 1 D, and S2n would be 2n by 2, 2a plus 2n minus 1 D, right? Now we have to utilize this given equation. S2n equals to 3 times Sn. So basically 2 times n by 2 times 2a plus 2n minus 1 D equals to 3n by 2, 3 times n by 2, basically 3 times Sn, 3n by 2, 2a plus n minus 1 D. So n by 2 gets cancelled. So this becomes 4a plus 4nd minus 2d equals to 6a plus 3nd minus 3d. So eventually it becomes 2a. This gets cancelled, becomes 2a. This gets cancelled, becomes minus nd. This gets cancelled, becomes minus d equals to 0. So basically 2a equals to n plus 1 times d, right? We have got this particular relation. Now we have to find out the ratio of these two terms. So S3n divided by Sn. So that would be 3n by 2, 2a plus 3n minus 1d divided by n by 2, 2a plus n minus 1d. So n by 2 gets cancelled out. So it becomes 3 times. I can replace 2a with n plus 1d. N plus 1d plus 3n minus 1d divided by again n plus 1d plus n minus 1d. I can see that this 1 gets cancelled out and d is also getting cancelled out. It becomes 3 times, this is 4n divided by 2n. So 6 is the correct answer. B is the correct answer. Now let's look at this question. If the sum of first n terms of two APs are in the ratio 3n plus 8 is to 7 plus 15, 7n plus 15, then the ratio of their 12th term is. So let's write the given conditions first. Sum of n terms of first two APs. So basically there are two APs. So let's say A1 and D1 is the first parameters for first AP, and A2 and D2 are the parameters for second AP. So we have been given that the ratio are in this particular format. So n by 2 times 2a1 plus n minus 1 d1 divided by n by 2 times 2a2 plus n minus 1 d2. This is equals to 3n plus 8 divided by 7n plus 15. So this gets cancelled out. So if I take 2 as common over here, 2 times a1 plus n minus 1 d1 divided by 2 times n by 2 over here plus n minus 1 by 2 times d2. This is a2. Okay. So this gets cancelled. Why I did that? Because we have to find out the ratio of 12th term. In if you're writing Tn, in that case we have a1 plus something n minus 1d, right? In that kind of format. So that's why I've taken 2 out of here. Now we have to find out the value of ratio of their 12th term. So that would be a1 plus 11d d1 divided by a2 plus 11d2, right? We have to find out this ratio. Now this is equals to 3n plus 8 divided by 7n plus 15. Now I can put some value of n over here that would make this 11, right? And over here as well, that would make this 11 because we have common terms, common, that is n minus 1, 2 over here in the numerator and n minus 1 by 2 in the numerator as well. And over here as well, we have 11 and 11 in both numerator and denominator. So basically I'll put out n equals to 23 and that would give us the equation exactly as this one. So if I put out n equals to 23 over here, I will be getting a1 plus 23 minus 1 by 2, that is nothing but 11 d1 divided by a2 plus 11 d2, same thing. And basically I have to put 23 over here because this value is same as this value and we'll get the answer for this particular thing. Okay, you can do the maths afterwards. The main thing was the approach. Now let's look at some important results. Sum of first n natural numbers. So everyone knows that that is n times n plus 1 by 2. Let's see how we derive it. Basically, we have a equals to 1, we have b equals to 1. If you talk about the progression AP of natural numbers and natural numbers, we have a equals to 1, d equals to 1. So basically, we'll be getting n by 2 times 1 plus n minus 1 times 1, right? So that would eventually give me n times n plus 1 by 2. So you have to remember this one. Now, although these two are not APs, but we'll be remembering the formulas for the same. So for sum of n natural numbers, that would be n times n plus 1 by 2. For sum of squares of n natural numbers, that would be n plus 1, 2n plus 1 divided by 6. We have to remember this. So this is sigma n square. This is sigma n. And the third one is sigma n cube. That would be n plus 1 by 2 whole square. So basically this is sigma n cube is nothing but sigma n whole square. Okay, so you have to remember these three formulas by heart. Now the last important result is Tn equals to Sn minus 1. That is again very intuitive, right? So let's say we have Sn equals to T1 plus T2 plus T3 and till Tn. And if I'm writing Sn minus 1, basically over here we have n terms. In case of Sn minus 1, we will be having n minus 1 terms. T1 plus T2 plus T3 till Tn minus 1. So 1 over here we have n minus 1 terms. Over here we have n terms, right? Now if I subtract both of them, so Sn minus 1. So this gets cancelled out, this gets cancelled out, this gets cancelled out, and this also gets cancelled out. Only the remaining term would be Tn. So this you have to remember. Sn minus 1 minus Sn minus 1. Sn minus Sn minus 1 equals to Tn. Okay. Now let's look at one question. If Sn denotes the sum of n terms of an AP, then Sn plus 3 minus 3 times Sn plus 2 plus 3 times Sn plus 1 minus Sn equals to. So what I can do over here, I'll write Sn plus 3 minus, I'll take 1 Sn plus 2 from here. For the obvious reasons, because I want to create that difference. And let's write it as minus Sn plus 2 minus 2 times Sn plus 2. And similarly for over here, because that would give me Sn plus 1 minus Sn. So I'll take 1 Sn plus 1 from here. So 2 times Sn plus 1 plus Sn plus 1 minus Sn. Okay. Now this becomes Tn plus 3. And this becomes, if I take minus 2 from common over here, Sn plus 2 minus Sn plus 1 plus Sn, and this basically becomes Tn plus 1. So this eventually becomes Tn plus 3 minus 2 times Tn plus 2 plus Tn plus 1. So basically what I'll be doing, I'll be writing this as a plus n plus 3 minus 1 d, basically using the formula for general term, minus 2 times a plus n plus 1 d plus a plus n d, right? So this is n plus 2d. Okay. Now I can clearly see that a gets cancelled out from everywhere. So we are left with nd plus 2d minus 2nd minus 2d plus nd. So nd and 2nd gets cancelled, and 2d and 2d gets cancelled out. So the answer is 0. So today's lecture was still here only, and I think it was quite basic. Just few stuff which was in addition to the what we have studied in 9th and 10th class, right? So from tomorrow onwards, we'll be starting with geometric progressions and harmonic progressions, and let's meet tomorrow. Thanks for watching.